The one thing I should point out with respect to the little experiment that we're doing here is that this particular problem of Digital Simplex blocking occurs irrespective of brand, and that's the reason why these two radios have their are blinded, so you can't actually see the brand, and this radio here is also blinded, so you can't see the brand. Both of these radios conform to the ETSI DMR Tier 2 standard, so that's European Standards Telecommunications Institute DMR Tier 2, and we've done this experiment with other radios and also with other analog radios in the mix. So what I'm going to do is I'm going to encourage you to actually do the same experiment with your own radios, and all you need here is two digital mobiles, a simplex channel, get them to communicate with one another, and then put an analog radio on the same frequency, analog, put a CTCSS tone on it if you wish, and do the same experiment, and I'm sure you will actually get the same result. But I encourage you to do that because the experiments that we've done, the brand, this problem occurs with Digital Simplex irrespective of brand. We have here two digital radios. This digital radio is operating into an RF load via my bird meter. This digital radio is going into the RF load in my comms test set. You can tell that they're actually digital radios because if I key this up and speak, there will be a slight delay. A slight delay is caused by the vocoder in the radio. That's a voice encoder decoder. So this one encodes it and that one decodes it, and there will be a slight delay. Test 1, 2, 3. And back the other way. Test 1, 2, 3. Now that slight echo is the encoder and the decoder doing its thing. So these two radios are digital and they're simplex. So we've got RF communications directly between one radio and the other. Now the purpose of making this video is to demonstrate digital channel blocking. We have here an ordinary analog radio. I've blinded the maker's marks and things off this ordinary analog radio. If I key this radio up, it's transmitting on an analog channel on the same frequency as the digital radios, and you can see the green light on the front of these radios. They're actually indicating that both those radios are receiving this analog signal. Now that's not unusual in New Zealand because exclusive channels, exclusive simplex channels, are only available to government departments. If you're a business in New Zealand, you can't get an exclusive simplex channel. The purpose of this video is to demonstrate digital channel blocking, and I'm going to do that very simply. I'm going to transmit with this radio. It'll be you'll be able to hear it in that radio, and at the same time I'm going to key up here. Now when a digital, you've just seen me in an analog radio. When I transmit my analog radio, the digital radio can see it, but it just brings up the indicator light. The same thing occurs in the opposite direction. The analog radio can see it, but you get very little indication off the analog radio. Here it is there. Again, a little green light. There's not much to the analog user to indicate that there's somebody else on the same frequency, and vice versa. There's not much to the digital user to indicate that somebody's operating an analog radio on the same frequency. So here's the demonstration of digital channel blocking. Here we go. What I'm going to do is I'm going to transmit onto this. You'll hear the audio coming out of there, and right in the middle of it I'm going to push the PTT button on this analog radio, and you'll hear the audio stop. Test 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. Now, that's a serious problem. If you've got a Simplex Digital service somewhere in New Zealand, they're using this digital radio for critical operations such as crane control or anything where the radio communications is mission critical, and you're using digital. So we've got this mission critical audio going on, and right in the middle of it somebody with an analog radio comes in and transmits and blocks your communication signal right out. Once the analog signal has stopped transmitting, I'll just lift my finger off the button, you'll get your digital back again. Now that's obviously a serious problem and constitutes a serious health and safety risk to the user of these digital radios, who, if they're using them for mission critical communications, they can be easily blocked with an analog radio. What's perturbing is that this information is not well known in the industry. Now, my recommendation to you, if you're in the radio industry and you're marketing digital radios to customers and you're supplying these digital radios to them, and you're supplying them to them in with a Simplex channel, Digital Simplex channel, you really should be advising them that they shouldn't be using this radio for mission critical communications for exactly that reason. One more demonstration. Here's the digital signal started up, and I'll just go test call, and right in the middle of it I'll transmit with my handheld radio, and there we go, it's blocked it out. And I'll let the button on my handheld radio go, and you will get your audio back again. Over to you guys in the industry to assess the risk to your customers, and of course the health and safety risk to your own business if you don't advise your customers that this phenomenon actually exists.